19. Ah, damn it! Started over.
Hey Jeff, what are you playing over here?
Just playing Snake and trying to get the high score.
High score? I mean, I can beat your high score in one sitting. You got this.
No way.
Give me that game.
Get out of here.
What?
Maybe lose.
Hey, you know you're working something else besides that one game, right? You're working that 4 weeks.
I got plenty of time. Plenty of time.
You have one more sensor to make and you have not done anything with it.
Dude, don't worry about it. Just give you like after 5 minutes. 5 minutes.
Jeez, whatever. Hey, you know what Grenquist says when you don't finish on time?
What's that?
Trust me, I'm an engineer. I think we put this thing right here. Trust me, I'm an engineer. What the fuck did just happen here? Trust me, I'm an engineer. Oh shit, I think I'm out of here.
Okay, so here's the schematic for Snake. We have the joystick down here. We have the VCC pin connected to 5 volts. We have the vertical connected to analog input 1. The horizontal connected to analog input 0. Then we have it grounded right here. Okay, so over here we have the LED matrix, and all the rows we have resistors. They're 220 ohms. Okay, here's the code for the Snake. We're first going to initialize all of our pins, and then we're going to go into setup and set the 7 segment to an output, the joystick to a matrix. Then we're going to set the food position at a random spot. Then we're going to write all the columns low and the rows high. We're going to set the rows high so we can set them low, so that we can pass current to those pins. Then we're going to come to the loop. We're going to read the joystick. And here we're going to, the Snake X and the Y value are going to take the position of the 18, and the 18s are going to take the positions of the 17s, so that it looks like it is following the last one. Here we're going to take if the direction is 1, we're going to increment the Y position of the head of the snake up. If it's 3, we're going to decrement it, going downwards, and then we have left and right. Then we're going to say if the snake head on the x-axis is equal to the food of the x-axis, and the snake y value is equal to the food y value. Then we're going to randomize the new food position and increase the length of the snake. Here we have the x, which is going to be if x is greater than or equal to 1, as in we're going to put an x on the screen. If the snake hits a wall, we're going to count this 100 times. We're going to go through this code 100 times, and it's going to turn on the LEDs that correspond with the x, and it's going to flash one at a time, so it looks like they're all on at the same time. And then we're going to say we're going to write x to 0. We're going to write the snake length to 1. The the snake position is going to be in the middle. We're going to randomize the new food position, and then we're going to set x1 to 0. Here we're going to do the snake speed, and then here it says if the snake length is 20, we're going to reset it back to 1. So while the count is less than or equal to speed, we're going to the snake length equals 1. We're going to take the snake x position, and we're going to write whichever one corresponds with it, high, and then low. And this will turn one LED on at a time. We're going to delay for a second. Then we're going to write all these low again, write all these high, and then it'll go on all the way up to 20, turning one position of the snake on at a time. And then we'll go through the count again, and we'll set the count to 0, and we'll repeat the process.
Survey says. What's going on with you? Jeff, what are you doing? What's that noise?
Jeffrey!
that in your hand?
Nothing.
What are these matches doing here?
Nothing. Just holding them for a friend, you know.
Are you smoking a cigarette inside, Jeffrey?
No.
Do you know what happens when you smoke inside?
Okay, so here's the flame sensor circuit for the Arduino. We have 5 volts coming to the 5 volt rail of the breadboard, and we also have ground coming to the ground rail of the breadboard. Over here we have the flame sensor. The analog output pin goes to the analog input on the Arduino. We also have a ground that goes to the ground rail of the breadboard, and the VCC pin that goes to 5 volts. Over here we have an LED that goes to pin 9. Pin 9 goes to the blue lead, and over here the red lead goes to pin 10. And since this is a common cathode LED, this pin right here will go straight to ground. And we also have the piezo speaker. The piezo speaker is grounded to the ground rail, and the other pin is going to pin 11 so that we can toggle it on and off. Okay, so this is the code for the flame sensor. In the loop here, we're going to read the encoder value, and then we're going to check and see if the value of the flame sensor is less than the threshold, and if it is, we're going to write the buzzer high and delay it, then we're going to write it low, and then we're going to write the LED, turn it on, delay that, then we're going to turn it off. We're going to read the encoder again, we're going to wait, and then we're going to turn the LED 2 on, then we're going to wait, and then we're going to turn LED 2 off, and then we're going to delay that and read the encoder value again. And then if the value is greater than val 2, we're going to write everything low because no fire has been detected.
Yeah, Zay, what are you working on?
I'm finishing up the infrared controlled air conditioner. Just gotta plug in the power.
Wait, you sure you want to do that?
What's the worst that could happen?
You know what? You'll be fine. Uh-oh. Isaiah! 3 times this week.
Here we have the wiring diagram for the infrared receiver module that connects to the Arduino to control the thermostat. Obviously there are 3 main parts of this circuit. There's the infrared receiver module, which is right here, which contains a sensor and some circuitry to modulate the signal. Then we have the Arduino, which retrieves the value from the receiver and determines what to do with it. And finally we have the output relay right here, which actually controls the thermostat on or off itself. The code itself is a little bit complex, but it's, overall it's quite simple and short. The first thing we need to do is write a sketch that retrieves the actual value from the infrared remote, and that I did in a different program. And I found out that when I press the power button on my remote, this is the value that is returned. So that's what I'm using as the control to turn the thermostat on and off. So the next thing we need to do is retrieve the value from the sensor. Once we retrieve the value, we're going to check and see if it matches the signal that we received earlier, and that is that the power button was pressed. And if it is, we're going to activate the relay and turn on the LEDs. And if it's not, we're going to turn off that LED, turn on another LED, and turn off the relay. And this would disconnect power to the module, thus turning it off. So this right here is the original module. We just connected the power through the relay, and the relays and the sensor are connected to the Arduino, and then it's connected through the module. So if I press the power button on the remote, it turns the system off. And if I press it again, turns the system back on again.
Nah, it's got to be right. All right, let's go check it out.
Let's check it out. Oh my goodness.
Hey, Isaiah, you know why it's so cold in here?
Oh, he's playing with the air conditioner again.
Cut it out, all right? No more.
Playtime a little bit.
Dave, don't you think it's a little bit hot in here?
Jeff, not only is it hot, it's getting hotter.
Yeah, that thing's definitely right. Hopefully it's not Isaiah again.
Son of a gun.
Oh God, not again.
It is hot out here.
This is the DHT11 sensor. The DHT is a basic digital temperature and humidity sensor. It uses a capacitive humidity sensor and a thermistor to measure the surrounding air, and it spits out a digital reading on the data pin. Using the Arduino Uno, we can take in readings from the DHT11 and display them onto the 16:2 liquid crystal display. So the last thing I wish to talk about before getting into the code is the RGB LED. So as of now, I have the RGB LED to turn 3 different colors depending on the temperature. So right now, it will turn blue if it is below, say, 60 degrees, and it'll turn red if it's above, say, 73 degrees. And anything between that will be like the Goldilocks, like just right temperature. We begin displaying onto the liquid crystal display. I'll bring up a picture of it. Here it is. Now we start with the temperature on the first row, as you see here, and then same with the humidity, but on the bottom row this time. After we have our LCD set up to display what we want it to, we can now move on to the loop. So here we're using the variable TF, which we declared earlier. And we're converting it from Celsius to Fahrenheit, and from there we're just declaring HUM as the humidity. Both of these are defined in the header file of the DHT, and from there we print it on the serial, and then from there we display the temperature reading onto each line respectively. So right here we have temperature displaying after the word temperature, and humidity displaying after humidity. Now the final part of our code is for the RGB LED. So now we have, if the temperature is less than or equal to 60 degrees, we'll turn only the blue LED on. If the temperature is above 73 degrees, we'll turn only the red LED on. And if the temperature is anything between these two temperatures, it will turn on the green LED, signifying a comfortable temperature. As you can see here, the temperature reading of the DHT11 says 59 degrees, and the LED is blue. Now the temperature is 68 degrees Fahrenheit, which is within our comfort zone, so the LED is green. Finally, we're getting a reading of 73 degrees Fahrenheit, which is outside of our comfort zone. It is too hot. Therefore, our LED shows red.
I'm so hungry. I don't want to go to the store. I wonder what Dave's got. Crackers, cereal, and I'll have some pasta. Come this time.
Going down. Gotcha. Gotta take my food again, aren't you?
No.
I put it there for a reason. I knew you were gonna take it again.
I was going to make you dinner.
Oh, really?
I was.
You know what happens when you take other people's food?
So here's the wiring diagram for the infrared proximity detector. Right here is the sensor. The analog output voltage is fed directly into the analog input of the Arduino. The Arduino then processes it and determines whether the voltage is above a certain threshold. If it is, it'll set off this piezo buzzer right here, and will also flash the LED, which is in parallel with the buzzer. The code itself is pretty simple. It simply reads the voltage off of the sensor and compares it to a certain threshold. If the value of the ADC exceeds that threshold, then it'll set off the alarm, and will also flash the LED at the same time.